All right, class, today I just wanted to go over in a little bit more detail a concept from Chapter 7, and that's rationalizing denominators. So, when we're rationalizing the denominator, that's when we take a square root or a radical, okay, from the denominator and move it to the top. So what we want to do is we're trying to make our denominator a rational number. We don't want a number that looks like 1 over the square root of 2, okay? Now, there's nothing wrong with an irrational denominator. It still works, but it's not technically in its simplest form. So I just wanted to show you guys how to do that. So, rationalizing a denominator is the same as finding an equivalent fraction. So remember that irrational numbers are real numbers, and the fact that any number that's real over itself is equal to 1. Okay, that's one of the really unique properties of 1. So if I have 7 over 7, that's 1. If I have the square root of 3 divided by the square root of 3, that's 1. And if I have the square root of x over the square root of x, that is 1. And when we're working hard to find equivalent fractions, we just need to multiply by 1, and that 1 could be in any form. So in this example, I went through and I took 1/2 and I multiplied it by 1. In this case, it's up to form 3 over 3. That gives me 1 times 3 over 2 times 6, because when we're multiplying fractions, we multiply numerators and multiply denominators, and that gives me 3/6, okay? So I know that 1/2 and 3/6 are equivalent fractions. Now I could find any number of equivalent fractions to 1/2. So let's try another example. If I have 1/2 and I want to find an equivalent fraction, I could take 1/2 times, let's go with 7 over 7. 7 divided by 7 is 1, right? That gives me 7/14. So 7/14 is an equivalent fraction to 1/2 and 3/6. They all, if we were to simplify them, would be 1/2, so they're all equivalent. Now, we rationalize denominators by harnessing the power of 1, okay? I mentioned on the previous slide that irrational numbers are real numbers. So in order to rationalize the denominators, what we do is we multiply by the radical in the denominator over the radical in the denominator, because this equals 1. That gives me 1 times the square root of 2, and the square root of 2 times the square root of 2, which is 2. Okay, if you don't quite remember how I got there, you might want to look at the property of roots. Remember that the square root of 2 is the same as 2 to the 1/2. And if I took 2 to the 1/2 times 2 to the 1/2, when I am multiplying exponents with the same base, I add their exponents, and 1/2 plus 1/2 is 1. So I have 2 to the first, which is 2. Okay? If I multiply this through, I get the square root of 2 over 2. So 1 over the square root of 2 and the square root of 2 are equivalent. Now this is definitely harder to see than something like 1/3 and 2/6, right? We can see if we simplified this, we'd get back to 1/3. So this is a little harder to see, but they are equivalent fractions. So I'm going to go through quite a few more examples of how to rationalize denominators. So here I have 2 over the square root of x. I'm going to take the square root of x over the square root of x. That gives me 2 square root of x over x. And that is my rationalized denominator. Another way to think of this, as opposed to having the square root of x be x to the 1/2 and multiplying that way, remember when we're multiplying radicals, we multiply what's under the radical. So this would give me the square root of x squared. Square roots cancel squares, which gives you x. Okay, now I have 2 square root of 6 over the square root of 3. I'm going to multiply by the square root of 3. That gives me 3 over 2 square root of 3 times 6, which is 18. And I need to fully simplify the square root of 18. Remember, 18 factors into a 2 and a 9 and a 3 and a 3. So the square root of 18 is the same as the square root of 2 times 3 squared. And square roots cancel squares, so I have 3 square root of 2. So that leaves me with 2 times 3 square root of 2 over 3. So I have 6 square root of 2 over 3. And 6 divided by 3 is just going to give me 2 square root of 2 for our final answer. All right, now I have the square root of 3 over 2 square root of 5. Note, I don't want to multiply by 2 square root of 5. I just want to make the denominator a rational number, so I'm only going to be multiplying by the square root of 5. That gives me the square root of 15 over 2 times 5, which is the square root of 15 over 10. I can't simplify the square root of 15 anymore because 15 is just 3 times 5. So here we have found our two equivalent fractions, this one being the one with a rationalized denominator. All right, now I have 3 square root of 2 over the square root of 18. Now, first thing I need to do is simplify. That's going to give me 3 square root of 2 over 18, which I know factors to 3 square root of 2. 3 square root of 2 over 3 square root of 2 is 1. Okay, this isn't quite the example I meant to do. Let's try this again. So what if I take the square root of 20 over the square root of 2? That's better. Well, I'm going to simplify 20. 20 factors into a 4 and a 5. 4 is 2 squared. So I have 2 square root of 5 over the square root of 2. Now that I've fully simplified, I'm going to go ahead and multiply just by the square root of 5. So that gives me the square root of 10, which I can't simplify any further, over 2 times 5. So I have the square root of 10 over 10. Next, I have 4 over I. Remember that I is the square root of -1. So technically it is a radical, okay? What I'm going to want to do is multiply I on the top of the bottom. Remember that I squared, well, that's the same as I times I, which is the square root of -1 times the square root of -1, which is just going to give you -1. Okay, something to keep in mind. So now I have 4I over I squared. Well, I squared is -1. 4I over -1 is just going to be -4I. So it's always important to remember that imaginary numbers are a radical, right? They're a square root, and I need to remember to rationalize the denominator. I believe this is our last example. I have 2I. Remember, I just want to multiply by I on the top and the bottom. And I'm going to have to distribute the I. So that gives me 3I plus I squared over 2I squared. So I have 3I plus -1 over 2 times -1. So I have -2 over 3I minus I. Now remember, when we have imaginary numbers, we want it to be the real part plus the imaginary part. So we want it to look like A plus BI, or it could be A minus BI, right? So I'm going to rearrange my numerator to be -1 plus 3I over 2. Now, if you're doing your homework by hand, this is equivalent to this. If you are doing your homework online and have to submit it into something like My Math Lab or Learning Management System, it's going to want your answer in this form, or it may count it as wrong.